All right, number one, we have a graph of a function here, f shown in the plane above, for what value of x. So remember, we're looking at x values, so that's these numbers down here. For what value of x is the value of f of x? Remember, anytime on a function question, f of x is really just the y values. What is the value of y at its minimum? So minimum, we're looking at the lowest point. So looking at y values, this would be the lowest y. All right, that's the minimum. But the question said, what is the x value? What value of x? So the value of x is going to be at -1, -2. Looks like right there at -3. So the correct answer is B. Number two, the graph of y equals f of x is shown above. What is the value of f of 0? So f of 0 basically just means you're going to put, look at where x equals 0 and then find out what y is. So we kind of put that 0 in right there. So at x equals 0, it looks like y equals 4. So f of 0 equals 4. Correct answer is D. You always want to think of the graph as kind of like an XY table. All through algebra, you do a lot of T-charts and XY tables. And then all of a sudden they start calling things f of x. The big thing that you really need to remember is that the x value is your input and the y value, or the f of x, is your output. So when you're kind of looking at this problem, you're putting in 0, and then we're wanting to know what is the y value when you input the 0. And right there, that point, 0, 4, gives you that answer. In the xy plane, the graph of the function f of x equals x squared plus 5x plus 4 has two x-intercepts. What is the distance between? So that's kind of the key thing we need to focus on. The distance between x-intercepts. All right, well, let's think about the graph of this thing. If this was on the calculator version, I could use a graphing calculator, but since this is no calculator, we need to be able to sketch this. First thing I see is that this is a quadratic, all right? It's y equals x squared plus 5x plus 4. And whenever I have a quadratic, I always want to try to factor it because usually that gives me some information. And remember, if you're an x-intercept, that means your y value is 0. You're on the x-axis somewhere. So that means that you live somewhere on this line right here. So let's go ahead and let's set this up equal to 0. And I'm going to attempt to factor this. So what I need to be able to do is I need to be able to find two numbers that can multiply to make him and add to make him. So the two numbers, I think, are 4 and 1, and both positive. All right, so what I've just did, these numbers right here, these are called factors. And once you lock down the factors, if something times something equals 0, one of these two have to be equal to 0. So you just kind of solve the two cases, and you say, all right, x plus 4 equals 0 when x is -4. And this side, x plus 1 is going to be 0. And you probably don't even have to write this out. You could just solve it in your head, I'm sure. They're pretty much opposites of those up above. So these right here, these two, they are my intercepts. So I'm going to go put them on the graph. I'm going to put one here at -1, and then the other one at -2, -3, -4. Since there's a positive in front of the x squared, I know that it's basically going to come down and go up somehow. But the key thing that we wanted to find was what was the distance between those. So how far is it between -4 and -1? Well, that's a distance of 3. So the correct answer, C. Number 4, the complete graph of function f is shown in the xy plane above. Which of the following are equal to 1? So the big question here is, which one of these people here are equal to 1? Now, being equal to 1 means that when you plug in these x values right here, who's going to come out to give you a y value of 1? So let's kind of go through. F of -4, we'll take care of this first one. F of -4, Well, if you input -4, 1, 2, 3, 4, you get an answer of y equals 1. So the 1 works. So we can eliminate that answer. We can eliminate that answer because B and D still have 1 in there. The next one says, what about when you put an input of 3/2 or 1.5? An input of 1.5 is right there, which is also worth 1. So we know that 2 works. That kind of wipes out B. What we're left with is D. Let's just double check and make sure that the third one works. When I input that 3 right here at f of 3, it looks like the y value is also 1. So basically, when you plug these x values in, they all have a 1 for the y value. All of those points are on there. So the correct answer here is D. Number 5. And the function f has 5 distinct zeros. So there's our first clue. 5 distinct zeros. That distinct kind of means different. So you don't have a double root. Just one quick thing I want to kind of break down. In general, if normally you have a quadratic, let's just say, that comes down, and right there that means it has 2 zeros. And if you have a situation, and that would be 2 distinct zeros, if you had a situation where you had a quadratic come up and just kiss it, all right, just one spot, it actually has 1 distinct zero. All right, it's called a double root, but it's 1 distinct zero. And then sometimes it's just up here floating and it doesn't touch at all. So this has no distinct zeros or no real zeros. Which of the line could represent a complete graph in the xy plane? So we're looking for 5 places where you cross, this x-axis. That's what we're kind of looking for. Where do you cross the x-axis? So on this first one, 1, 2, 3, 4. So that has 4 distinct zeros. So that's out. The next one, 1, 2, 3, 4. So you're out. This one right here has 1, 2, 3, 4, 5. Ooh, that one has 6. Hopefully this last one works. 1, 2, 3, 4, 5 zeros. 5 different distinct zeros. Correct answer, D. 3, the graphs of functions f and g are shown above. Which of the following value of x? So we're trying to figure out a value of x such that f of x plus g of x needs to come out to be 0. So that's what we're looking for. And let's just kind of color code these. The g of x we'll do in red. So that's this one. And then the other one we'll do in blue. All right, well, those curves represent f of x, or the y value. So kind of what we're looking for his y value and his y value when we add together the y values to get 0, but for the same x. So let me just kind of give you an example of somewhere maybe where it doesn't work. And I want to kind of darken in where these are. I wish they made them a little bit darker because it's kind of hard to see exactly where the grid is. But let's just take a number, for instance, like, I don't know, let's look at x equals 0. All right. If you look at x equals 0, well, x equals 0 is here. You get 2 y values. You get a y value on the blue function, on the f function, of -1. And then if I looked at when 0 on the red function, that's going to be way down here. And I can't even really tell where it crosses, but I'm thinking maybe right about there, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, like 9 or 10. Either way, I can tell that's not going to be equal to 0. Now, the one place that I do notice is right here. I have a y value of 2 and a y value of -2, which are going to come out to be 0. And that occurs right here. If this is 0, x equals -1, that's x equals -2 right there. So correct answer, B. Number 8, in the xy plane, the graph of the function f has x-intercepts. All right, so that's important. We're talking about the x-intercepts. At -3, -1, and 1, which of the following could define f? So the first thing to understand is all of these are written in factor form. okay, which means they're kind of in parentheses like that. So if I kind of think about my graph, x-intercepts are basically where we cross, this x-axis somewhere. So they're telling me that I have x-intercepts at -3, -1, and 1. So I have an x-intercept right here, an x-intercept right there, and then another x-intercept over here. Well, the key thing that you need to know are these x-intercepts, or these zeros, are basically where my factors are going to be 0. So if I look at factors, this factor is going to be x plus 3. Notice if you plug -3 in for x, it makes the expression 0. This factor is going to come out to be x plus 1, and this factor is going to be x minus 1. All of these zeros make these factors here worth 0, so you can kind of think of them as opposites a lot of the time. So I'm looking for the equation that has those factors, so the correct answer here is going to be C. All right, number 9, looks like we have a graph of a cubic. Remember, cubics kind of always, they do something like this, or they can come down, finish down, something like that. But we have a cubic is graphed in the plane. If k is a number, or a constant, so k is just some number, such as the equation f of x equals k, and remember, I always just think of f of x as y, so as y equals k, has 3 real solutions. So this is kind of the key part. They want us to have 3 real solutions. Well, a real solution is basically an x-intercept. It's where you cross the x-axis. Right now, there's only one real solution sitting right there. If y equals 0, or 1, 0, it says which of the following could be the value of k. So we want to have 3 solutions. So remember, y equals k is basically a horizontal line, all right, going left to right. And so, like, for instance, if we had a line, like let's say we wanted to graph y equals 3, all right, well, the graph y equals 3 would be this line right here, all right, but that would only have one solution because it only crossed it once. But if I look down right here, all right, right at this spot, if I focus on that line, I think that's the one horizontal line where I am going to get, 1, 2, 3 solutions. So my line needs to be y equals -3, okay, or f of x equals -3. So the correct answer there is D. All right, the figure on the left above shows a wheel with a mark on the rim. So it looks like the mark on the rim is right there. The wheel is rolling on the ground at a constant rate, so that's important. It's not changing speed, along a level straight path. The graph of y equals d of t on the right could represent which of the following as a function of time from when the wheel began to roll. So notice that we have time down here on the bottom, and we're trying to figure out, what could this represent over here? And it looks like we're changing from like a high to a low, to a high, to a low, to a high. So that graph is changing over time. So it cannot be A. A says the speed. Well, the speed can't change because they told me that it was constant. How about the distance of the wheel from the starting point? I don't think that one's correct, because a graph of the distance from the wheel, if this was the distance, over time, you'd be getting further and further away from the starting point. So it cannot be B. C, the distance of the mark on the rim from the center of the wheel. I think if we were to graph that, the distance from the center of the wheel remains unchanged. It's always going to be whatever that radius is from the center to the edge. I think the correct answer here is going to be D, the distance of the mark on the rim from the ground. So right now the mark on the tire is high. Well, as that ball rolls, it's going to come down, and this red mark will come right down there and be at the ground. Then it goes back to the top of the wheel, back to the ground. So the correct answer here is D. Number 11, looks like we have a function and some graphs. The function f, and it's kind of blurry, I apologize for that, but the function f is defined by the equation above. So let me just kind of rewrite this thing. I like to use y. Y equals 2 to the x power plus 1. So we know that this is an exponential function, all right? And all exponential functions kind of start slow and go faster and faster. If we wanted to, we could actually make a little XY table just to kind of see what this dude looks like. And I always like to start off by putting 0 in. So if you put 0 in for x, 2 to the 0 power is 1, plus another one would give me 2. So if I were graphing this here, I guess I should probably put some other parts. But I know that 0, 2 lives on the graph. If I put a 1 in for x, that would be 2 to the first plus 1, which is 3. So over 1, up 3. If I slap a 2 in there, that would be 2 squared, which is 4 plus 1. That's 5. So not constant, getting steeper and steeper. And basically the graph is going to look something like that. That's a rough sketch of what this person right here looks like. Now, what does the question want to know? The question says, which of the following is a graph of y equals negative f of x? Okay, so if f of x represents y, we need all of our y's to go from positive to negative. All right, so if all of my y values trade places and become negative, that y would bounce down here, this y would bounce here, and basically you kind of have this mirror image, all right, where it's actually a reflection over the x-axis, or like a horizontal reflection or a flip. So our right answer should be a line that looks like this red one. These two are going the wrong direction. This one looks kind of good, but realize it crosses at 1. We need to cross at 2. So the correct answer here is C. Alright, the graph of a linear function f is shown in the plane above. So right here, this line is f, and we could actually write an equation for that line if we wanted to, but let's see where we're going. The slope of the graph of a linear function g, so now they're bringing up some new line, g, actually I'm going to make this person in red, g is 4 times the slope of f, and then g also goes through a point 0, -4. Alright, so a couple things before we get started. I need to kind of darken this in because I don't like it when they don't make the axes a little bit darker. So now I can kind of see what's going on a little bit better. And I have an idea about this g function. This g function crosses at 0, -4, which would be right down here. Now let's look at the slopes. So if I were to look at the slope of the f line, because they kind of give me g as a clue, the f line has a rise of 1 and a run of 2, so it's kind of an up 1 over 2. So this f function has a slope of 1/2. So if I wanted to actually write an equation for that line, I know it's going to be y equals 1/2 x. And looking at the y-intercept, 1, 2, 3, it crosses at 3. So remember, in general, y equals mx plus b is your general formula for a line, where m is slope, b is the y-intercept. So I have an equation for f, which can predict any point on the line. I'm going to try to do the same thing for g. So if g has a slope that's 4 times f, so my g line has a slope that's 4 times, kind of shrink this back down here, it has a slope that's 4 times that number. So 4 times 1/2 is 2. So I know this g function is y equals 2x. And then I can see the intercept was at -4. That was helpful. So now I have an equation for g. And it says, what is the value of g of 9? Well, g of 9 basically means I'm just going to plug 9 in for x. So 2 times 9, take away 4, which is 18, take away 4. So it looks like g of 9 is 14. Now you could have just tried to keep graphing it. A slope of 2 would have been up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. But you would have had to go a long ways to get all the way out here to 9. So the formula was quite a bit faster. Number 13. In the xy plane, the point 2, 5. So right there, they're giving me an x and a y combination that lies on the graph. This is super important. Whenever they tell you on the SAT that something lies on a graph, that means that you can substitute it in, okay, or plug it in somewhere. So it says if f of x equals, so remember f of x is just y, if y equals k minus x squared, where k is a constant, so k is just some number, what is the value of k? Well, to solve for k, what I need to do is I need to plug in this xy they give me. So plugging in the 5 for y, and then plugging in the 2 for x, I get 5 equals k minus 4. And then adding 4 to both sides is going to tell me that k equals 9. So correct answer is 9. Number 14, I have a graph of a function. We also have a table. It says the complete graph of the function f. So let's just kind of, this right here represents f. And then we have a function g is over here in the table. And it says the maximum value of f is k. So the maximum value of f is k. Well, I can see where the maximum value is. The maximum value is right there, which is 3. So there's the maximum value of f. And then it says, what is the value of g of k? So we know that k equals 3. So now we can just substitute it in. Actually, I guess I should put this in red. G of k is, well, I go to my table, and when you put 3 in, g of 3 is 6. So the correct answer here is B. Number 15, looks like we have a quadratic. It's kind of inverted, going upside down. So it says the graph of the function f is defined by f of x equals negative 1/2, blah, 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 shown in the xy plane above. If the function g, which is not shown, is defined by, so they're giving me an equation. Let me just kind of jot that down. So I know that g of x is negative x plus 10. This is going to be kind of helpful because the slope is negative 1, so whatever's in front of the x term. And then the y-intercept is going to be positive 10. So that's going to help me graph that thing. So let me just kind of, well, let's finish the question here. What is one possible value of a such that f of a equals g of a? So if you look right here, the two functions are going to be the same, meaning their y values are going to be the same for the same input a. So the key idea for this is, when is that going to happen? Well, it's going to happen when these two graphs intersect. All right, so we're kind of looking to see when f and g intersect. So this part right here, this is our f. That's f. And then let's graph g. We have some key information here about g. G starts off with an intercept at 10. So there's g's y-intercept. Slope is negative 1. So negative 1 means that I'm going to go down 1 and then right 1. So down 1. Oh, be careful. I almost put the dot here, but look at the bottom, how it skips. Be very careful of that. I've made a lot of mistakes over the years when they do this to me and they change the grid. So every square is worth a half. So I need to go right 1, down 1, right 1, down 1. So there's an intersection point. Right 1, down 1, down 1, down, down, down. So it looks like there's two correct answers for this one. So one correct answer is, actually, I don't want that number because it says, what is one possible value of a? I want the input. So the input is basically our x. So it happened right here at 2, and then it happened right here at 8. So you could either put 2 or 8, and you would have the correct answer. When they use the word possible, that pretty much lets you know there's going to be more than one answer that's correct. 16, looks like we have a graph of some sort of function, y equals f of x. The figure above shows a complete graph of function f. The function g, which is not shown, so they tend to do that a lot, is g of x equals f of x. So right now they'd be the exact same thing. But then when you add a +6 on there, basically what it does, it's going to shift the graph up by 6 units. So you're going to take this graph and you're going to kind of come up 6 units. So that'd actually be, you know, up here somewhere like that. What is the maximum value of G? Well, right now the maximum value of F, the maximum height, is sitting right here at 2. So if we shift it up by 6 this way, it's going to put our new tops. So this new top right here is going to be at 8. So the correct answer here is 8. The graph of the linear function f is shown in the xy plane above. The graph of g, which is not shown, is perpendicular. So there's our first clue. It's perpendicular, which, remember what perpendicular means back in geometry class. That means that it's 90 degrees to f, and passes through the point 1, 3. So we need to be perpendicular to f, and we need to go through the point 1, 3. So the point 1, 3 is right there. Now, to be perpendicular to f, let's kind of figure this out. Well, first of all, we need to find the slope of f. All right. So the slope of f is, you know, change in y over change in x, or it looks like we're dropping 2 and then we're running 1. So since we're falling, it's going to be a -2/1, or a slope of -2. Now, I kind of like to leave it as a fraction, because when you want to make something perpendicular, so let's kind of focus now on what the slope of g needs to be. If I want to be perpendicular, what I need to do is I need to do two things. I need to flip these two, so I need to be the reciprocal, or I need to flip it, and I need to have the opposite sign. So those are the two key ingredients that you got to do when you want to be perpendicular. So if I flip that and I change the sign, it's going to make my slope be a +1/2. So now my line has got to be +1/2 is up 1 over 2. And if I go back the other way, it's going to be right kind of here. So there's a line that's perpendicular to f. It goes through the point they said. And then now we need to know, what is the value of g when 0 is inputted? Well, the value of g when 0 is inputted is right here. And it looks like it crosses perfectly at 2.5. Now, when you enter this on the SAT, since this is a free response, you could enter 2.5, or you could enter 5/2. Either way would be acceptable. The graph of the exponential function h in the xy plane, where y equals h of x, has a y-intercept of d, where d is a positive constant. So first thing we need to know is that d is some sort of positive number. Which of the following could define h? So first clue here is the graph of an exponential function. So remember what an exponential function is. Exponential function means you start slowly and then you build really fast. That would be exponential growth. The other way would be decay. So let's kind of look through which of the following could define h. So first of all, two of these are not even exponential functions. Exponential function is an example would be like y equals 2 to the x. The key is that you want x to be the power for exponential. So for instance, this is linear. It doesn't have any powers, power of 1. This one right here has a power of 3 because it's a cubic. So you're out. You know, he would look something like that. This one would just be some sort of line. Actually be negative, but doesn't really matter. So A and D, if you had it down to a 50-50, you're going to want to pick A or D here. The problem with A is you have a negative coefficient out in the front. So what that's going to do is that's going to make this thing come down instead of up. And that would violate, it says that we have a y-intercept of D, and D has to be positive, which means it needs to cross up here. So you're going to be out. So the correct answer here would be D. All right, that one is going to give us some sort of a graph where regardless of what D is, it's going to kind of go up this way and D is going to be up here. In the xy plane, the graph of a polynomial function f crosses the x-axis at exactly 2 points, a, 0, and b, 0, where a and b are both positive. So which of the following could define f? So a key thing here that you need to know is, first of all, if you cross the x-axis at exactly 2 points, all right, another name for this, these are called solutions, or sometimes they're referred to as zeros, or sometimes they're referred to as roots. They all kind of mean the same thing. It's where you cross the x-axis. Well, it's said for this problem that a and b are both positive. So it looks like both of our solutions are going to be over here on the x side. So the big thing you need to know is all of our answers here are written in factor form. And the key idea is factors are different than solutions. So for instance, if we put these on here, let's just call this point A, and this one is going to be point B. If those are our roots, then that means that our factors are where these are 0. So you're going to have like x minus A and x minus B, because when you substitute, when you put that 0 in right there, you're going to get A take away A, and what we're looking for is one of these factors going to be 0. So you can kind of think of factors as the opposite of these. So the correct answer here would be minus B minus A. Correct answer would be A. Which of the following is an example of a function whose graph in the xy plane has no x-intercepts? So I cannot have an x-intercept. So let's just look at the options here. So part A, a linear function, so a line whose rate of change is not 0. So rate of change of not 0 would be, something like this or something like that. And either way, I'm going to have an x-intercept somewhere. The only way I couldn't is if my rate of change was constant. So A is wiped out. What about a quadratic with real zeros? Well, if I'm looking at B, a quadratic with real zeros means that it either comes down and goes up, or goes up and comes down, and I end up having these zeros here, or x-intercepts. So that one's out. Part C, a quadratic with no real zeros. So a quadratic with no real zeros basically means you're floating either below or above, and no real zeros mean you're going to have no x-intercepts. So the correct answer here is C. Let's just look at D, a cubic polynomial with at least one real zero. So, that's going to be something like this. This one actually has 3. But the key idea here is that zeros are x-intercepts. So if you have no x-intercepts, you want to have no real zeros.